All right, oh man, I forgot to turn off the camera. Oh well, you can look at my profile for a bit. So we're gonna take a look at some more solving, and I gotta tell you, number 8, there's a little trick to it. So here we go. So for number 7, we have 3 to the x minus 1 is equal to 9 to the x plus 2. Now, for us to solve this, we really want to have things in the same base. And 3, well, I can't really reduce 3 at all. So really we have 3 to the x minus 1, but I can't help but notice that 9, oh yeah, 9 can be turned into some 3's, right? So another way of saying 9 is just 3 squared. So we have 3 squared, and we're taking that to the x plus 2 power. Now, when we are taking a power to another power, we multiply, which means we're going to end up with 3 to the x minus 1 is equal to 3 to the 2x plus 4 power. Well, wait a second. If 3 to the x minus 1 power equals 3 to the 2x plus 4 power, that means x plus 1 has to equal 2x plus 4. So we have x minus 1 is equal to 2x plus 4. All right, so then subtract x, and we get negative 1 is equal to x plus 4 minus 4, and so we get x is equal to negative 5. Now I'm just going to check my notes, make sure I got the same answer again, and I did. And the thing is, this problem wasn't asking what x is equal to, it was asking what is 2x plus 4. Well, if x is negative 5, I just plug that in. So we have 2 times negative 5 plus 4. 2 times negative 5 is negative 10, maybe. There we go, negative 10 plus 4. Negative 10 plus 4 is negative 6. And it's always great when you get the same answer twice. All right, number 8, I can't lie, I forgot something when I was doing number 8. So let's get started. So we have 4 times 2x plus 1, and that's to the 2/5 power. That's kind of weird. And then we have plus 3 is equal to 19. Well, let's get rid of what we know how to get rid of really easily. So I'm going to subtract 3 from both sides, and I get 4 to the 2x plus 1 to the 2/5 power is equal to, well, 19 minus 3, well, that's just going to be 16. I like that because 16 is divisible by 4, and so we get 2x plus 1 to the 2/5 power is equal to 4. Now this is where things get a little bit funny. To get rid of the exponent of 2/5, well, what am I going to do? I'm going to take everything to the 5/2 power. So if I take everything to the 5/2 power, that's going to leave me with 2x plus 1 is equal to 4 to the 5/2 power. Now this is where I made my mistake. 4, taking the square root of 4, well, so the square root of 4 is equal to 2. Obviously 2 times 2 is 4, but since this is an equation, we could also have it equal to negative 2, because negative 2 times negative 2 is also 4. So that gives me the possibility of 2 different answers, one positive and one negative. Now, I can't help but notice that this problem asked us to find the negative solution, which means I'm not going to bother with this at all, because it specifically said when x, it wanted me to solve this when x is less than 0. So I'm going to go ahead with 4 to the square root of 4 being negative 2. So we have 2x plus 1 is equal to negative 2. Obviously it could be positive 2 as well, and I could split it into positive and negative worlds, but I'm not going to do that because the directions tell me only do the negative. So we solve to the 5th power. Negative 2 to the 5th power, well, that's just negative 32, because since it's an odd power, I'm going to still have a negative answer. So I get negative 32 2x plus 1. All right, so now I'll subtract 1, and so I'll get 2x is equal to negative 33. So then divide both sides by 2, and so I'll get x is equal to negative 33 over 2. Or I can put it as a decimal, and that would be negative 16.5. Now, unfortunately, this is not our answer. We want to find 2x, and oh, yep, right there it says only when x is less than 0. So plug that into 2x, which actually, well, did I have to do this whole piece here? No, because I know that 2x is equal to negative 33. So that just means it's negative 33. And there's my solution. Sorry about having to look at me.